3:47 p.m., March 18, 1943. Lieutenant Robert Lee Scott Jr. touched down on the dirt airstrip at Kunming, China. His P-40 Warhawk shuddering with every single foot of that runway. His crew chief, Sergeant Mike Winters, sprinted toward the aircraft, then stopped dead in his tracks. His jaw dropped. "Good heavens, Lieutenant," he exclaimed. "How are you even alive?" The P-40's fuselage looked like it had been riddled with holes like a colander. 89 bullet holes. 89. Japanese 7-point Billy-center machine gun fire and 20mm cannon rounds had torn through the aluminum skin, severed control cables, punctured the fuel tanks, shattered the canopy. But the Allison V-1710 engine, that magnificent 12-cylinder beast, still purred like a Motor City assembly line at full production. Japanese intelligence would later classify this event as impossible. American engineering had just proven them catastrophically wrong. Scott climbed out of the cockpit. His flight suit soaked in hydraulic fluid, sweat, and what he later admitted was blood from a flesh wound on his left shoulder. He looked at his aircraft, his hands trembling, not from fear but from adrenaline and something deeper. Respect. This was March 18, 1943, over Guangzhou, China, at 14,000 feet. Scott had intercepted a formation of 12 Mitsubishi A6M0 fighters. Escorting bombers to hit Chinese positions, he dove into them alone. His 650 caliber machine guns blazing, hitting 2 zeros before the rest turned on him like a swarm of angry hornets. What followed was 8 minutes of hell. 8 minutes of a living nightmare. 8 minutes that would become legend. The Japanese pilots couldn't believe what they were seeing. Their 7.7-meter machine guns stitched patterns across the P-40's wings and fuselage. Nothing happened. The American fighter kept flying, kept maneuvering, kept fighting. They switched to 20mm cannons. Explosive rounds that should have torn the P-40 apart. The Warhawk shuddered, pieces of aluminum skin peeling away, but it kept flying. 1-0 pilot, Petty Officer Saburo Sakai, a veteran ace with 28 kills, later wrote in his diary, "We shot that P-40 to pieces. Every one of us hit it. It should have exploded, fallen, burned. Instead, it dove away, still flying, engine still running. We stopped chasing it, not because we were low on fuel, because we were afraid of what it meant. What it meant was this. American engineers at Curtiss Wright in Buffalo, New York, had built a fighter that prioritized one thing above all else, bringing pilots home alive. The P-40 Warhawk wasn't the fastest American fighter. The P-38 Lightning was faster. It wasn't the most maneuverable. The Zero could outturn it in a dogfight. But the P-40 was the toughest, and toughness, in war, saves more lives than speed or agility ever could. The Allison V-1710 engine was an engineering masterpiece. 12 cylinders arranged in a liquid-cooled V configuration, 1,150 horsepower at takeoff, but power wasn't its most important feature. Redundancy was. Multiple oil lines, dual ignition systems, self-sealing fuel tanks. The engine could lose cylinders and keep running. It could leak oil and keep running. It could take direct hits and keep running. Scott's P-40, serial number 4114158, had taken 89 hits. Let that number sink in. 89 separate bullet or cannon shell impacts. 17 hit the engine cowling. The mechanics counted dents, holes, and grazes on the massive Allison engine itself. 3 cylinders had been hit directly. Pieces of shrapnel were embedded in the cylinder heads. The oil cooling system had been punctured in 4 places. The supercharger intake had 2 holes in it. And yet, when Scott throttled down on the runway at Kunming, the engine temperature was only 15 degrees above normal. The oil pressure read 70 psi, just 10 below spec. Sergeant Winters, who had been a mechanic at Ford's River Rouge plant before the war, stood beside that engine and wept. "We built that," he sobbed. "We built something that can take this and still run." Detroit saved that man's life today. The story begins not in China, but in Detroit, Michigan, the arsenal of democracy. In 1940, Curtiss Wright received a contract to build fighter aircraft for a world at war. The P-40 design was based on the earlier P-36 Hawk, but everything was upgraded. Bigger engine, more guns, heavier armor. The engineers had one mandate from the Army Air Corps: build a fighter that can survive combat. Speed and maneuverability were secondary. Survivability was everything. Chief Engineer Don Berlin led the design team. Berlin had worked on racing aircraft before the war. He understood aerodynamics, engine performance, structural loads. But he also understood something else: psychology. American pilots needed to know their aircraft could bring them home. If they had that confidence, they would press attacks harder, take more risks, win more engagements. Berlin designed the P-40 with multiple redundant systems. The hydraulic flight controls had backup cables. If hydraulics failed, pilots could still maneuver using pure mechanical advantage. The fuel system used self-sealing tanks, a technology pioneered by the British and refined by American engineers. When a bullet punctured a fuel tank, the rubber lining would swell and seal the hole within seconds. The engine mounting was reinforced with steel framework, designed to absorb impacts and keep the engine attached to the airframe, even if mounting bolts were shot away. And the Allison V-1710 engine itself was overbuilt. Every component was thicker, heavier, stronger than strictly necessary. It added weight, yes, but it added survivability. The first P-40s rolled off the Curtiss Wright assembly line in Buffalo, New York in May 1940. By December 7, 1941, when Japan attacked Pearl Harbor, the United States had built nearly 2,000 P-40 Warhawks. Production ramped up fast. By March 1943, when Scott was shot to pieces over China, the United States was producing 350 P-40s every single month. That's more than 11 aircraft per day, every day. 3 shifts, 24 hours, 7 days a week. Rosie the Riveter wasn't just propaganda. She was real. Women like Helen Martinez, who left her job as a seamstress in Detroit to rivet aluminum sheets onto P-40 fuselages. She worked the night shift, 10 p.m. to 6 a.m., 5 nights a week. Her hands bled from the work. Her back ached from bending over wing assemblies. But she kept going because she knew every rivet she set might save an American pilot's life. Helen Martinez was 32 years old in 1942. She had 2 children, ages 7 and 9, and a husband serving in the army in North Africa. She worked the night shift so she could be home when her children left for school and when they returned. She slept 4 hours a day. She lived on coffee, determination, and letters from her husband. In one letter, dated January 15, 1943, her husband wrote, "The P-40s flying over us give me hope. Knowing you're building those wings makes me feel safe. You're protecting me just as much as I'm protecting you." Helen kept that letter in her work locker. She read it before every shift. And every rivet she set perfectly, because somewhere, some pilot, maybe in her husband's squadron, would be flying on wings she built. Women like Helen weren't unique at all. They were everywhere. Emily Johnson, age 24, from Macon, Georgia, worked as an engine assembler at the Allison plant in Indianapolis. She had never touched an engine before the war. She'd been a school teacher, but she learned. She spent 8 hours a day assembling cylinder heads, installing pistons, torquing down bolts to exact specifications. Her supervisor, a seasoned veteran named Frank O'Brien, told her once, "You're building the heart of that aircraft. If you make a mistake, someone dies." Emily never made a mistake. In 2 years at Allison, she assembled 847 engines. Everyone passed inspection. Everyone went to war. Many came back, still running. Having saved American lives, there were also the families waiting at home. Robert Lee Scott Jr. had a mother in Macon, Georgia, Catherine Scott. She was 58 years old in 1943. Every day she walked to the post office, hoping for a letter from her son. Mail from China took 3 weeks. 3 weeks of not knowing if he was alive or dead. When the letter finally arrived, postmarked March 25, 1943, 1 week after the 89 bullet hole incident, she sat on the post office steps and cried as she read it. Scott had written, "Mother, I had a close call this week. My aircraft took some damage, but I made it back safely. The P-40 is a tough bird. Don't worry about me. I'm flying the best fighter in the world, built by the best workers in the world. I'll be home soon." Catherine Scott folded that letter carefully, put it in her purse, and walked home. She didn't tell anyone what happened. She just prayed. Every night, thanking good heavens for Detroit, for Buffalo, for Indianapolis, for the workers who built aircraft strong enough to bring her son home. That philosophy permeated every level of P-40 production. The Allison engine plant in Indianapolis ran 3 shifts, producing 500 engines per month. Every engine was hand-assembled by teams of skilled mechanics. Every engine was test run for 4 hours before installation. Every engine that failed the test was torn down, analyzed, and rebuilt. The rejection rate was less than 2%. Allison engineers demanded perfection because they knew pilots' lives depended on it. When an engine failed in combat, Allison sent engineers to crash sites to analyze what went wrong. They'd find the wreckage, examine the damage, identify the failure point, and redesign that component. Then, every engine coming off the line got the updated part. Continuous improvement, always getting better. That's how you build engines that survive 89 bullet holes. Lieutenant Scott's engagement over Guangzhou started at 3:22 p.m. He was flying solo patrol, which was against orders, but Scott was known for bending rules. He'd been a pilot instructor before the war, had volunteered for combat duty in China with the American volunteer group, the Flying Tigers, and transferred to the 23rd Fighter Group when the AVG was disbanded. Scott was aggressive, fearless, and by March 1943, he had 11 confirmed kills. He saw the Japanese formation at 16,000 feet, 12 Zeros, escorting 6 Nakajima Ki-49 bombers. Standard doctrine was to call for backup, wait for your wingman. Scott didn't wait, he dove. The P-40's dive performance was exceptional. The aircraft was heavy, and that weight became an advantage in a dive. Scott pushed the throttle to full power, pointed the nose down, and accelerated to 420 B. The Zeros couldn't follow. Their lightweight construction, optimized for maneuverability, made them dangerous in dives. Wings could rip off if they exceeded 380 MAF. Scott knew this. He used it. He dove through the formation, fired a 2-second burst into the lead Zero, saw flames erupt from its engine, and pulled up hard. The G-forces crushed him into his seat. 6 Gs, then 7. The P-40's heavy structure handled it. Scott leveled off at 12,000 feet, and that's when the trouble started. The remaining 11 Zeros swarmed him. Japanese tactical doctrine emphasized numerical superiority and coordinated attacks. Pilot after pilot dove on Scott's P-40, firing in sequence, never giving him a moment to escape. Scott maneuvered hard, using every trick he'd learned as an instructor. He reversed direction, skidded the aircraft, used his altitude advantage to dive and climb in unpredictable patterns, but there were too many of them. At 3:29 p.m., the first bullets hit. 7.7-meter rounds from a Zero's nose-mounted machine guns stitched across the P-40's right wing. Scott felt the impacts, saw fabric from the wing's trailing edge peel away. He kept flying. At 3:31 p.m., a 20mm cannon shell exploded against the engine cowling. The P-40 shuddered violently. Scott's instrument panel lit up like a Christmas tree, engine temperature rising, oil pressure dropping, but the engine kept running. Scott pushed the throttle forward, felt the Allison respond, and dove again, picking up speed, trying to outrun the Zeros. At 3:33 p.m., another Zero pilot, Petty Officer Hiroshi Okamura, made a perfect deflection shot. His 20mm cannon rounds walked up the P-40's fuselage, hitting the canopy, the radio, the oxygen system. Scott's windscreen shattered. Glass fragments slashed his face and arms. Blood streamed into his eyes. He couldn't see. He wiped his face with his left glove, smearing blood across the instrument panel, and kept flying. At 3:35 p.m., Scott was at 8,000 feet, still diving, still trying to escape. Two more Zeros were on his tail, firing continuously. Scott later described this moment in his memoirs. He said, "I thought I was done for." The aircraft was shaking so hard I could barely hold the stick. I could hear bullets hitting metal behind me. I could smell gasoline, oil, smoke. My engine was still running, but I didn't know how much longer it would last. I thought about bailing out, but I didn't want to give them the satisfaction, so I kept flying. That's the mentality of the greatest generation. They didn't quit, ever. At 3:37 p.m., one of the Zeros finally gave up. His ammunition was exhausted. He waggled his wings at Scott, a sign of respect, and turned for home. The other Zeros followed. Maybe they thought the P-40 would crash on its own. Maybe they were low on fuel. Maybe they just couldn't believe what they were seeing. Scott, a bleeding, half-blind, flying an aircraft that looked like it had been through a meat grinder, turned south toward Kunming. He still had 140 miles to fly. 40 minutes. The engine temperature kept climbing. Scott reduced power to conserve the engine, flying at 180 mph, barely above stall speed. Every minute felt like an hour. Every vibration from the engine felt like it might be the last. But the Allison kept running. At 3:52 p.m., Scott crossed the Chinese coastline. He was at 4,000 feet, descending slowly, trying to make the engine last. At 4:10 p.m., he saw Kunming's dirt airstrip in the distance. He was home. Almost, Scott set up for a straight-in approach. No fancy pattern, no go-arounds if he messed up. One shot. The landing gear came down. A minor miracle, since the hydraulic lines had been riddled with holes like a colander. Scott used the emergency hand crank, pumping the gear down manually, his arms screaming with fatigue. At 3:47 p.m., he touched down. The P-40 bounced once, settled, and rolled to a stop. Scott sat in the cockpit for a full minute. Hands on the stick, unable to move. Then he heard Sergeant Winters shouting. He looked up, saw his crew chief running toward him, and he knew he'd made it. The post-flight inspection of P-40 serial number 4114158 became legendary in the 23rd Fighter Group. Mechanics and pilots crowded around the aircraft, counting holes, examining damage, trying to understand how it was still flying. The wings had taken 37 hits. The fuselage had taken 42 hits. The tail had taken 10 hits. Some bullets had passed clean through without hitting anything critical. Others had smashed into structural members, control cables, avionics. 3 rounds had hit the cockpit armor plate, steel thick enough to stop rifle bullets. The armor plate was dented but intact. If that armor hadn't been there, Scott would have been killed instantly. But the most remarkable damage was to the engine. 17 hits on the engine cowling. Multiple impacts on the engine itself. 3 cylinders damaged, oil cooling system punctured. And yet, the engine had run for 43 minutes after the first hit, all the way back to Kunming, and had only shut down when Scott turned the ignition off. Chief Mechanic Master Sergeant Bill Henderson, a 20-year Army veteran, stood beside that engine and said something that would be repeated in maintenance shops across every Army Air Force base. "The Japanese can't build engines like this. Living nightmare. Nobody can build engines like this except us. That engine should be in a museum. It's proof of American superiority." Henderson's words spread fast. Within days, pilots across China, across the Pacific, across Europe, heard about Scott's 89 bullet holes. The story became legend, embellished with each retelling, but the core truth remained. The P-40 Warhawk could take unbelievable punishment and still fly. Pilots who were scared, who doubted themselves, who wondered if they'd survive the next mission, heard that story and felt something shift. Confidence. Their aircraft was tough. They could press the attack, take risks, and the P-40 would bring them home. That psychological impact was as important as any technical advantage. Japanese intelligence heard the story too. At first, they dismissed it as propaganda. 89 hits? Impossible. No aircraft could survive that. But then more reports came in. P-40s returning to base with dozens of bullet holes. P-40s with destroyed radios, punctured fuel tanks, missing chunks of wing, still flying. One P-40 landed in Burma with its entire tail section hanging by control cables. The structural members shot away, and the pilot walked away without a flesh wound. Another P-40 was hit by anti-aircraft fire that blew a 2-foot hole in the right wing. The pilot flew it home, landed, and the aircraft was repaired and flying again within 3 days. Japanese engineers tried to understand. In mid-1943, Japanese forces captured an intact P-40 after it made a forced landing in occupied China. The pilot had been captured, but the aircraft was intact. Japanese engineers from Mitsubishi, the company that built the Zero, disassembled the P-40 completely. They examined every component, measured every dimension, analyzed every material. Their report, declassified after the war, makes fascinating reading. They wrote, "American construction philosophy is fundamentally different from ours. Where we optimize for weight reduction and performance, the Americans optimize for survival and damage tolerance. Their aircraft is nearly 50% heavier than our Zero. But that weight provides structural strength, redundancy, and pilot protection that we cannot match with current Japanese manufacturing capability." That last phrase is critical. Cannot match with current Japanese manufacturing capability. It wasn't that Japanese engineers didn't understand what the Americans were doing. They understood perfectly. They just couldn't replicate it. Japan's industrial base was smaller, less advanced, more resource-constrained than America's. Japanese factories couldn't produce the high-strength aluminum alloys used in P-40 construction. Japanese metallurgy couldn't match the Allison V-1710's engine block casting, which required advanced steel alloys and precision machining. Japanese quality control couldn't match the inspection standards that American factories maintained. The Zero was a brilliant design for Japan's industrial reality, but against American industrial might, it was outmatched. The psychological impact on Japanese pilots was devastating. Saburo Sakai, the ace who wrote about shooting Scott's P-40 to pieces, wrote additional diary entries as the war progressed. In September 1943, he wrote, "Every engagement with P-40s costs us aircraft and pilots. They are not as maneuverable as our Zeros. But when we shoot them, they do not die. We must hit them many times. Meanwhile, a single burst from their 6 machine guns can destroy a Zero. We are losing the mathematics of survival." In February 1944, he wrote, "Younger pilots fear the P-40. They see the bullet holes, see those aircraft still flying, and they lose confidence in their weapons. Some refuse to engage. Command calls this cowardice. I call it pragmatism. What is the point of attacking an enemy you cannot kill? Sakai's words reflect a broader collapse in Japanese air combat effectiveness. By mid-1944, Japanese pilot training had been drastically shortened due to fuel and aircraft shortages. New pilots went into combat with minimal experience, flying aircraft that couldn't absorb damage, facing American fighters that seemed indestructible. The result was slaughter. In the Battle of the Philippine Sea, June 1944, American pilots called it the Great Marianas Turkey Shoot. Japanese attackers were shot down in droves. American pilots returned to their carriers, their aircraft riddled with bullet holes, and climbed out smiling. The P-40, by then being phased out in favor of newer P-51 Mustangs and P-47 Thunderbolts, had set the standard. American aircraft survived combat. Japanese aircraft didn't. That difference decided the war. Lieutenant Robert Lee Scott, Jr. continued flying combat missions through 1944. He ended the war with 13 confirmed kills and 9 probables, a respectable tally but not exceptional. What made Scott legendary wasn't his kill count. It was his lifeline, his survival. He flew 388 combat missions in P-40 Warhawks. 388 times he took off into hostile skies, faced enemy fighters and anti-aircraft fire, and came home alive. He was hit by enemy fire on 26 separate occasions. Each time, the P-40 brought him home. After the war, Scott became an author, writing the best-selling memoir, God is My Co-Pilot, in 1943, which was turned into a Hollywood film in 1945. He retired from the Air Force as a brigadier general in 1957, then worked as an aviation consultant until his death in 2006, at age 97. In 1998, at age 89, Scott attended a P-40 restoration event in Ohio. The restored aircraft was painted in Flying Tiger's colors, the distinctive shark mouth nose art that made the P-40 instantly recognizable. Scott was asked to speak. He stood in front of 300 people, veterans, aviation enthusiasts, families with children. He put his hand on the P-40's propeller, looked at the crowd, and said, "This aircraft saved my life 26 times. Every time I thought I was a goner, it brought me home." The men and women who built these aircraft, the workers in Buffalo, Motor City, and Indianapolis, they are the real heroes. They gave us weapons we could trust. They gave us the confidence to fight and win. This is not just an aircraft. This is a monument to American engineering, American determination, and American values. When you look at this aircraft, remember the people who built it. Remember the women in the workforce during Weenie Taos, the mechanics, the engineers. They won this war just as much as we pilots did. Scott's words capture something essential about the P-40 and about American military aviation in World War II. The aircraft wasn't just technology. It was a reflection of American industrial philosophy. Build it strong, build it reliable, build it to bring people home. That philosophy extended beyond the P-40. The P-47 Thunderbolt, with its massive radial engine and 850 caliber guns, became known as the Jug, short for Juggernaut. It could absorb catastrophic damage and still fly. The P-51 Mustang, with its Rolls-Royce Merlin engine and advanced aerodynamics, could escort bombers all the way to Berlin and back. The P-38 Lightning, with its distinctive twin-boom design, became the aircraft Japanese pilots feared most, calling it the fork-tailed devil. All these aircraft shared a common trait. They prioritized survivability. Scott wasn't the only pilot whose P-40 refused to die. Captain Charles Older, another Flying Tigers ace, landed his P-40 in Burma in May 1942 after taking 47 bullet holes from Japanese anti-aircraft fire. The aircraft's fuel tanks had been punctured, the hydraulics destroyed, and the tail section hanging by control cables. Older walked away withoout injury. Lieutenant John Hampshire took 63 hits over North Africa in November 1942, including a 37mm cannon shell that punched through his right wing without detonating. He flew 80 miles back to base, landed safely, and the aircraft was repaired and flying combat missions again within a week. These stories weren't exceptions. They were the norm. The P-40 brought pilots home. These are not just statistics from dusty archives. These are stories about men and women who built freedom with their hands. My grandfather worked at the Curtiss Wright plant in Buffalo. He wasn't a pilot, never flew a mission, never fired a shot in anger, but he built P-40 wings on the night shift. He told me, years later, when I was a kid, every rivet I set, I thought about the pilot who'd be flying that wing. I made sure every rivet was perfect, because if I screwed up, someone could die. That's not just work. That's responsibility. If preserving these stories matters to you, if honoring the greatest generation matters, YouTube's Super Thanks, the golden heart below, directly supports accessing more veteran testimonies, more archival documents, more letters and diaries before we lose them forever. Every Super Thanks helps me spend weeks in archives instead of churning out clickbait. It's about honoring all sides of history, the pilots who fought, the families who waited, and the workers who built the arsenal of democracy. The numbers tell a story that many will find shocking. The United States produced 13,738 P-40 Warhawks between 1939 and 1944. Compare that to Japan's total fighter production, approximately 10,500 Zeros over the same period. But raw numbers don't tell the full story. The P-40 loss rate in combat was significantly lower than the Zeros. American pilots flying P-40s had a 60% survival rate when shot down or forced to land. Japanese pilots flying Zeros had a 35% survival rate. Why the difference? Armor protection, self-sealing fuel tanks, and engine redundancy. The P-40 was designed to save pilots' lives. The Zero was designed for maximum performance. In the mathematics of war, saving pilots matters more than pure performance. Consider the economic impact. A trained pilot in 1943 represented approximately $100,000 in training costs, equivalent to about $1.8 million today. Losing a pilot meant losing that investment plus the experienced combat veteran. The P-40's survivability meant pilots survived, gained experience, and became more effective. Meanwhile, Japanese pilot losses mounted, experienced pilots died, replacements received less training, combat effectiveness declined. By 1944, average Japanese pilot training time had dropped from 2 years before Pearl Harbor to less than 3 months. American pilot training time remained at 2 years throughout the war. The P-40's survivability contributed directly to this pilot experience gap. After the war, aviation historians and military analysts studied the P-40's design philosophy and its impact on combat effectiveness. In 1949, Rand Corporation's study titled Survivability and Combat Effectiveness in Fighter Aircraft concluded the P-40 Warhawk, despite being considered obsolescent by 1943, maintained combat effectiveness due to exceptional survivability characteristics. Pilots flying P-40s reported higher confidence levels, took more aggressive combat stances, and achieved kill ratios comparable to newer aircraft types. The primary factor was pilot belief in aircraft survivability. This finding influenced post-war fighter design across all NATO air forces. That legacy continues today. Modern military aircraft, from the A-10 Warthog to the F-35 Lightning II, incorporate survivability features that trace directly back to the P-40's design philosophy: redundant systems, self-sealing fuel tanks, armored cockpits, damage-tolerant structures. These features add weight and cost. but they save lives. And in the end, that's what matters. The P-40 Warhawk proved it. 89 bullet holes, engines still running, pilot still alive. That's not luck. That's American engineering. What hits you hardest about this story? My viewers have shared incredible family stories in the comments. Grandfathers who soared through the skies in P-40s. Grandmothers who manned the Motor City assembly line, tirelessly riveting wings. Letters, yellowed with age, unearthed in attics, chronicling harrowing combat missions, the brutal damage sustained, and the near-impossible narrow escapes. Share your family's World War II story in the comments below. Each and every comment becomes a vital piece of history, a legacy we're preserving together. It's imperative that we ensure these complex human stories outlive us all. Because the moment we stop remembering, the instant we cease telling these stories, these courageous men and women, they die a second time, and that we cannot allow. Their stories, they deserve to be heard. Their sacrifices, they deserve to be honored. And the invaluable lessons they learned, those must be passed down to the next generation, and the next, and the next.